My name remains Chukwu Nelson, the DOS of Best Brain Tutor House. We are still looking at spontaneity of reaction, subtopic entropy and Gibbs free energy. Please don't forget to like, share, subscribe in order to get more of our new videos, which are free. Now, entropy as a case study. First, what is entropy? Entropy is the degree of disorderliness. Entropy is the degree of disorderliness or randomness of a chemical reaction. Is the degree of disorderness or randomness of a chemical reaction. That is what we call entropy. Now, entropy is denoted as change in X. Change in X is given as what? Change in H over what? Over T. Where my change in H here simply means what? Enthalpy. Simply means enthalpy. And my T here means temperature. My T here means temperature. Now, the degree of randomness or disorderness simply depicts or explains what entropy is all about. That's to say that the ability of what? Of a substance to move or reaction to undergo a random form or disorderliness form shows what? Its entropy process. Now, like I said, it is denoted as change in X, and change in X given as what? Change in H over what? Over T. Now, for we to be discussing or be describing randomness to compare entropy, it simply means that we will compare it to what? To the state of matter. We have three states of matter, which are solid, liquid, and gas. Among the three states of matter, gas have the highest entropy. Why? Because gas molecules tend to what? Move more faster, more than every other molecules or every other state. Why? Because gas molecules are held together by a weaker force. By so doing, their degree of randomness or disorderness tend to be higher than every other state of matter. Now, it simply means by going with this chart, we can say entropy of gas is greater than entropy of liquid. You understand? Then the list is now what? Entropy of what? Of solid. Entropy of solid. That's to say that what? That gas have the highest entropy, then the next is liquid, then the least is what? Solid. Even solid does not have entropy. Now, gas have the highest entropy from this chart. You see, gas, then liquid, then the least is what? Is solid. Like solid is crystal. Solid does not even have any entropy because solid does not what? Does not undergo disorderliness. Now, in this case now, we can say that what? In the state of matter, or let's say in this state of matter, gas have the highest entropy. Now, for entropy to be higher, it must be what? Positive in the system. And once it's positive in the system, it simply means that the reaction is going to be what? Fast. Or we say the reaction is going to be what? Fixable. Or we say the reaction is said to be what? Spontaneous. So it means what? A spontaneous reaction is that reaction that have an increased entropy. That is when entropy is positive, or we say entropy is greater than what? 0. Then when entropy is now less than 0, the reverse will occur. That is, there will be slow reaction, or we say no reaction, or there will be no reaction, or there will be non-spontaneous or no feasible process that will occur when entropy is less than 0, or we say entropy is what? Equals to negative. But when entropy is equal to 0, the reaction is said to be at what? Equilibrium form. Is said to be at equilibrium form. That's what tends to occur in the case of what? Of entropy. Now, trying to what? Describe increase and decrease in entropy using the change of state, or this chart that I will give to you now. That is what WAEC or JAM is always common to. If they are to ask you a question about what? Entropy, the first thing you must know is what? Trying to understand the state of matter. Then we have solid, then we have liquid, and we have what? Gas. When the substance is going from what? From liquid to gas, what can we call that? We call it evaporation. And when evaporation process occurs, is what kind of entropy change is that? Is a result of what? Of increased entropy. That means positive change in what? X. Because the substance will move from liquid state to gaseous state, there will be high degree of what? Of disorderliness. Now, on the reverse manner now, when the substance now move from gas to what? Liquid. What can we call that in change of state? We'll call it what? Condensation. We'll call it condensation. And when there's condensation, this occurs as a result of what? Of heat loss. When there's a loss of heat, a substance will change its state from gas to what? Liquid. Because when there's an increased what? Temperature, when there's an increased temperature, a substance change from what? Liquid to gas. But when there's now what? Loss of heat or decreased temperature, a substance move from gas to what? Liquid. And when a substance loses temperature, the entropy will now tend to what? Drop. Because the temperature would have increased the level of disorderliness. So that means here, change in S is equals to what? Negative. That is low or low entropy. Now, when a substance is going from solid to what? From gas to solid, we call it deposition in change of state. We'll call it deposition, or we can also call it what? We can also call it sublimation. Sublimation. You understand? In this case, for a substance to move from gas to solid, it simply means that what? Entropy will be decreasing. And this can only occur when there's what? A lower temperature. At lower temperature, my change in S is equal to what? Negative. Now, in the reverse manner, when the substance now moves from what? Solid to what? To gas. It's also known as sublimation. And when sublimation process occurs, the what? The temperature change here is what? Is increasing from solid to what? To gas. There will be an increase in what? Increased temperature. When there's an increased temperature, there will be an increased entropy. So here it means change in S is equals to what? Positive. Change in S here is positive. Take note. It's positive. Now, when a substance is moving from solid to what? To liquid, this will be achievable when there's what? A loss of what? Of heat. When there's a loss, when there's absorption of heat, when this one absorb heat, when this solid absorb heat, it will now melt into what? Into liquid. This occurs as a result of what? As a result of increase in temperature. When there's an increase in temperature to this solid, it will now change to what? Liquid. Now, it's changing from liquid, from solid to liquid. It is called what? Melting in change of state. And being called melting in change of state, that is increasing temperature, it means that entropy will also what? Increase, which will be what? Positive. Now, when a substance now moves from what? From a liquid to what? To solid state. What can we call that? We describe it to be called freezing. Freezing. Now, for a substance to change from liquid to what? To solid, it simply means that that substance have lost a lot of heat. Its temperature have reduced. When there's a reduced temperature or loss of what? Heat, the substance will have lesser energy to undergo what? Disorderliness. By so doing, we say that change in S is equals to what? Positive. Now, with the knowledge of this change of state, you can be able to answer any question that describe increase or decrease in entropy in what? In the chemical reaction. When the chemical reaction is occurring, the first thing you should take note of the change of state. In the gaseous state, take note, gas have the highest entropy. When the substance is going from what? From gas to what? To other state, entropy will decrease. When the substance is going from what? From other state to what? To gas, entropy what? Will increase. You understand? So just understand the what? The state of matter. With this, you can answer any question in that answers. Now, there is what we call law of thermodynamics. Law of thermodynamics also explains vividly about entropy. Though we have three laws of thermodynamics. We have the first law, we have the second law, then we now have the third law. Now, the first law is well spelled out in both biology and chemistry. I believe common, or how will I put it? Let me say original science student who is used to his book is supposed to know the laws of what? Of thermodynamics. Supposed to know at least the first law of thermodynamics. First law of thermodynamics. First law of thermodynamics. Now, what's the first law of thermodynamics? First law of thermodynamics states that energy can neither be created nor be destroyed, but can be transferred from one form to another. I take it again. Energy can neither be created nor be destroyed, but can be transferred from one form to another. That's the first law of thermodynamics. Now the second law of thermodynamics is stated in both chemistry and biology, but for now we are looking at the case of what? Of the chemistry. What is it saying? The second law of thermodynamics states that what? For a spontaneous process to occur, there will be an increase in entropy between the system and the what? The surrounding. Meaning that for us to describe a reaction to be spontaneous, it means there will be an increased entropy between the system where the chemical reaction is occurring and what? To the surrounding where chemical reaction is not occurring. Meaning that what? There will be loss of what? Of energy from the system into the what? Surrounding. That is what we call what? Second law of what? Of thermodynamics. Then the third law of thermodynamics says that what? The entropy of a crystalline object is said to be what? Zero. What does that mean? It simply means that what? Entropy is never found in solid. It means that solid does not have that degree of disorderness or randomness. That is why its entropy tends towards what? Zero. You understand? So that's the case of what? Of entropy as a case study. Now the last one here is gives free energy. Gives free energy. Gives free energy is the energy required to ascertain a work done. The energy required to ascertain a work done is described as what? As gives free energy. Now, gives free energy is denoted as what? As change in G. It is denoted as change in G. Change in G is equal to change in H minus T change in X. You understand? Now, this gives us the equation of what? Of free energy, which is what? Change in G. Now, whenever it happens to be that what? My change in H is what? Zero. That is at equilibrium. It means my what? My change in G is equal to minus T change in X. Now, when it happens to be that what? My change in G is greater than zero. It simply means that what? Change in H minus T change in S is what? Greater than zero. Greater than zero. Now, when it happens to be that what? This is now, when change in G is less than zero, it simply means that what? My change in H minus T change in X is less than what? Zero. That is, Gibbs free energy is less than what? Zero. Here, when Gibbs energy is greater than zero, there will be very slow reaction. There will be slow reaction here. No spontaneous process. Or we say it is non-spontaneous. Non-spontaneous. But when change in G is what? Is less than zero, that is tending towards negative. That is, my change in G is equals to what? Negative. It simply means here that what? My what? Reaction is said to be what? Spontaneous. It's said to be spontaneous. Or we say it's said to be fast, or we say it's said to be what? Fixable. It's said to be fixable. That is when it happens to be that my change in G is negative or is less than what? Zero. But when my change in G is what? Equal to zero, it's said to be at what? The reaction is said to be at what? Equilibrium. Equilibrium. Likewise entropy. Likewise entropy, zero, equilibrium. Likewise enthalpy, zero, equilibrium. That is, when enthalpy, entropy, and change in H is what? Is at zero, they are all tending towards what? Equilibrium. This describes enthalpy, entropy, and what? Gives free energy. Don't forget to like, don't forget to subscribe in order to get more of our new free videos. Thank you.